Glaciers are some of the most awe-inspiring and majestic features on Earth, stretching across vast expanses of land, moving ever so slowly but powerfully through mountains, valleys, and plains. Often called rivers of ice, they form from snow that has accumulated over thousands of years, compacted and transformed under immense pressure into dense ice. Glaciers seem almost eternal, ancient relics of a colder time, but they are far from static. They move, change shape, and even carve out entire landscapes as they slowly shift across the planet. To understand glaciers, one must first appreciate how they form. Unlike the snow that falls in our backyards and melts with the arrival of warmer weather, the snow that creates glaciers is special in its persistence. In regions of the world where temperatures remain cold year-round, snowfall accumulates over time, layer upon layer, never fully melting. This is common in high-altitude mountain ranges, polar regions, or areas near the Arctic and Antarctic circles. As the years go by, the weight of the new snow compacts the older layers beneath it, squeezing out the air trapped between snowflakes. Over decades or centuries, this compression transforms the snow into a dense, bluish ice. This glacier ice is much denser and more solid than the ice we typically find in our freezers, and it behaves differently under pressure. While glaciers may seem immobile to the naked eye, they are always on the move, albeit very slowly. This movement is driven by the immense weight of the ice and the force of gravity pulling it downhill. In fact, glaciers flow much like rivers, albeit at a glacial pace. The movement can range from just a few centimeters to several meters per day, depending on various factors such as the glacier's size, the slope of the land beneath it, and the temperature of the surrounding environment. Some glaciers move so slowly that their progress is imperceptible, while others may experience periods of rapid movement known as surges, where they suddenly accelerate for short bursts of time. As glaciers move, they carry with them debris, rocks, and sediment, all of which become embedded in the ice. This process, called plucking, occurs when meltwater at the base of the glacier seeps into cracks in the underlying rock. When the water refreezes, it expands and breaks off chunks of rock, which the glacier then incorporates into its mass. As the glacier continues to advance, it scrapes and grinds against the land beneath it, carving out valleys and shaping the landscape in a process known as abrasion. Over time, this constant grinding can create deep, U-shaped valleys, fjords, and other dramatic landforms that are hallmarks of glaciated regions. One of the most famous examples of glacier-carved landscapes is found in Yosemite Valley in California. The massive granite cliffs and U-shaped valley floor were sculpted by ancient glaciers that moved through the area millions of years ago, leaving behind a dramatic and breathtaking natural wonder. Similar glacial activity has shaped much of the world's mountainous regions, from the Alps in Europe to the Andes in South America. Despite their slow movement, glaciers can have profound effects on the environment. As they carve their way through mountains and valleys, they also transport vast amounts of sediment and debris, which is eventually deposited as the glacier melts. These deposits, known as moraines, can form ridges or hills of sediment along the glacier's edges or at its terminus, creating unique and varied landscapes. The glacial meltwater also feeds into rivers and lakes, providing a crucial source of fresh water for many ecosystems and human populations. But glaciers don't just shape the land through physical processes, they also play a critical role in regulating the Earth's climate. Glaciers act as giant mirrors, reflecting a significant portion of the sun's radiation back into space. This reflective capability, known as albedo, helps to keep the planet cooler by preventing the Earth from absorbing too much heat. When glaciers melt, however, this reflective surface is lost, and the darker land or ocean beneath the ice absorbs more heat, contributing to global warming. This creates a feedback loop. As the planet warms, glaciers melt faster, which in turn accelerates the warming process. This brings us to one of the most pressing concerns of our time, climate change and its impact on glaciers. Over the past century, glaciers around the world have been retreating at an alarming rate. Rising global temperatures, driven largely by human activities such as the burning of fossil fuels and deforestation, have caused glaciers to melt more rapidly than they can accumulate new ice. This has resulted in a dramatic reduction in glacier size and, in some cases, the complete disappearance of glaciers that have existed for thousands of years. The loss of glaciers has far-reaching consequences for the planet. Glaciers store a significant amount of the world's freshwater, and as they melt, they contribute to rising sea levels. This has already begun to have a noticeable impact, particularly in coastal areas where rising seas are causing increased flooding, erosion, and displacement of communities. In places like Alaska and Greenland, entire villages have had to relocate due to the encroaching waters. Glacier melt also disrupts ecosystems that rely on the steady flow of glacial meltwater. In mountainous regions, for example, glaciers provide a crucial source of water during the dry summer months, feeding into rivers and streams that support both wildlife and human agriculture. As glaciers shrink, these water supplies become less reliable, leading to water shortages and threatening the survival of species that depend on glacier-fed ecosystems. One of the most dramatic examples of glacier retreat can be seen in the Arctic, where the Greenland ice sheet is rapidly losing ice. Greenland's ice sheet contains enough water to raise global sea levels by about 20 feet if it were to melt completely. While such a catastrophic scenario is unlikely in the near future, the ongoing melting of Greenland's glaciers is contributing to a steady rise in sea levels that is already being felt around the world. Antarctica, too, is home to some of the world's largest glaciers, and the situation there is equally concerning. The Antarctic ice sheet is the largest single mass of ice on Earth, covering an area of over 5 million square miles. Like Greenland, Antarctica's glaciers hold enough ice to raise sea levels dramatically if they were to melt. In recent years, scientists have observed significant melting in West Antarctica, where large ice shelves are breaking off and drifting into the ocean. These ice shelves act as barriers, holding back the flow of glaciers from the interior of the continent. As they disappear, the glaciers behind them are free to accelerate their movement toward the sea, further contributing to sea level rise. While the situation may seem dire, there is still hope for the future of glaciers and the planet's climate. Efforts to reduce greenhouse gas emissions, transition to renewable energy sources, and protect natural ecosystems are all critical steps in slowing the rate of glacier melt and mitigating the impacts of climate change. Additionally, scientists are working to better understand the complex processes that govern glacier behavior, using advanced technologies such as satellite monitoring, ice core sampling, and climate modeling to predict future changes and develop strategies for adaptation. One fascinating area of research is the study of ancient glaciers and the climate records they hold within their ice. Glaciers are not just frozen rivers of ice, they are also time capsules, preserving layers of snow and ice that have accumulated over thousands of years. By analyzing ice cores drilled from glaciers, scientists can gain insights into past climate conditions, such as temperature fluctuations, atmospheric composition, and volcanic activity. These records provide valuable information about how the Earth's climate has changed over millennia and can help us better understand how it might change in the future. In some cases, ice cores have revealed surprising evidence of ancient climate events. For example, cores taken from the Greenland ice sheet have shown that during the last ice age, the climate experienced rapid and dramatic shifts, with temperatures rising and falling by as much as 10 degrees Celsius in just a few decades. These findings suggest that the Earth's climate system is capable of sudden and unpredictable changes, a sobering reminder of the potential consequences of today's rapid warming. Glaciers are also home to unique ecosystems that have adapted to survive in the harsh conditions of ice and cold. Beneath the surface of glaciers, in networks of tunnels and cracks, tiny organisms such as bacteria, algae, and even some forms of fungi thrive in the cold, dark environment. These microorganisms play an important role in the ecosystem, breaking down organic matter and contributing to nutrient cycles. Some researchers believe that studying these organisms could provide insights into how life might exist in extreme environments elsewhere in the solar system, such as on the icy moons of Jupiter or Saturn. In recent years, scientists have also discovered that glaciers can be much more dynamic than previously thought. While glaciers are typically associated with slow, steady movement, some glaciers can undergo rapid changes, moving at speeds of several meters per day during periods of surging. These surges occur when a glacier's internal pressure builds up, causing it to suddenly accelerate and flow much faster than usual. Surging glaciers can advance several kilometers in just a few months, creating dramatic changes in the landscape. One of the most famous surging glaciers is the Hubbard Glacier in Alaska, which has experienced multiple surges over the past century. During a surge in the 1980s, the glacier advanced so rapidly that it blocked off an entire fjord, creating a temporary lake. These surges are a reminder that glaciers, while seemingly slow and unchanging, are actually dynamic systems that can respond quickly to changes in their environment. Despite their importance to the planet's climate, ecosystems, and water supply, glaciers are often overlooked in discussions about climate change. Their remote locations and slow movements make them easy to forget, but the reality is that glaciers are at the front lines of the battle against global warming. The fate of glaciers is closely tied to the future of the planet, and their loss would have profound consequences for both nature and humanity. For many people, glaciers hold a special place in their hearts and minds. They are symbols of the wild, untamed beauty of nature, representing the power and majesty of the Earth's natural forces. But they are also fragile, vulnerable to the changes we are making to the planet. As we work to address the challenges of climate change, it is important to remember the role that glaciers play in our world and to take action to protect them for future generations. In the end, glaciers are not just frozen rivers of ice, they are dynamic, living systems that shape the landscape, regulate the climate, and support life in ways that we are only beginning to fully understand. They are a reminder of the interconnectedness of all things on Earth, and of the responsibility we have to protect the planet and its precious resources.